2004 BC test question number 6. F is a function given by f of x is sine of 5x plus pi over 4, and p of x is the third degree Taylor polynomial for f about x equals 0. We want to find p of x. Now there are two ways to go here. One way is to use what we know about the sine function. For example, we know that sine of x, the third degree polynomial for sine of x would just be x minus x cubed over 3 factorial. And I guess that we would try to replace every x with 5x plus pi over 4. And I guess it would look something like that. I'm really not too confident in using that. Let's look at the other way. Since there's not many terms involved, let's see what happens. So the original function is sine of 5x plus pi over 4. The first derivative would be 5 times cosine 5x plus pi over 4. The second derivative would be negative 5 squared sine of 5x plus pi over 4. And the third derivative would be negative still 5 cubed cosine 5x plus pi over 4. And I'm just going to take the stuff that we wrote before and move it out of the way so that I can calculate each of those values, evaluate them all at 0. Well, f of 0 would just be sine of pi over 4, which is root 2 over 2. F prime of 0 would be cosine of pi over 4, which is also root 2 over 2 times 5. The second derivative evaluated at 0 would be negative 5 squared, but still times root 2 over 2. And finally, the third derivative would be also negative 5 cubed and root 2 over 2. So these are the derivatives of them. And you can see that the first one, we could assume that that's 5 to the 0 times root 2 over 2. The second one, 5 to the first root 2 over 2. Third one, negative 5 squared root 2 over 2. Third derivative, negative 5 cubed root 2 over 2. So this one has an odd type of alternating pattern. It's positive, positive, negative, negative. We would assume that the next one would be positive. So let's just go ahead and calculate that, or find that just to see. Now, well, the derivative of cosine is negative sine, so those two negatives will cancel. And so we will indeed get 5 to the 4th sine of 5x plus pi over 4, and that will be positive. And the fourth derivative evaluated at 0 would be 5 to the 4th root 2 over 2. So we have enough information to begin working on this now. And I don't think that that shortcut method really led us to anything close to what we are seeing over here. So I'm going to scratch that. Why it didn't work? That's really hard to say, but if it's simple enough to calculate the derivatives, you may want to do both methods just to make sure that you have it you're on the right track there. If it's way too complicated to calculate the derivatives, you have to assume that the other way is going to work. So then p of x would be f of 0 plus f prime of 0 times x plus the second derivative of f evaluated at 0 times x squared over 2 factorial, and finally the third derivative of f evaluated at 0 times x cubed over 3 factorial. Well, the first term is 5 to the 0, which is 1, times root 2 over 2. Second term is 5 times root 2 over 2 times x. The third term would be 5 squared root 2 over 2 times x squared, and that's negative. And the fourth term, also negative, would be 5 cubed root 2 over 2 x cubed. And so that would be the third degree polynomial, Taylor polynomial for f about x equals 0. And of course we could simplify some of those numbers, but it really isn't necessary, and this will lead us to the general term much more straightforward. So you should see that sometimes you will be given a problem where you do need to actually construct the Taylor polynomial from the bottom up, as opposed to just transforming it from one of the big 7 that we do know. And it's not too difficult to do, and you should be good at it.